Hello. Today, we're going to keep building off of similar figures, just like we learned that in the previous lesson with previous similar figures. We do want to remember that the difference between congruency, which we learned the week before, is that congruency talks about shapes being exactly the same size and the same shape, whereas similar shapes, they have the same shape, but the size is different. But the size has to be different in a specific way. We have to remember that the size is different based on it's proportional. So there has to be one scale factor. Each line is proportional to the other. And so that's the difference between congruency and similar figures. And so when we looked at similar figures, we were able to figure out, well, how to write two shapes of are similar. The notation that we used here, which is what we're going to continue to use, and also looking at scale factors. Today, we're actually going to learn how to prove that two triangles are similar. Now, we've already done this with congruency. Remember, one of the chapters that we did, we had to prove that two triangles are congruent. In this case, we can now prove two triangles are similar with conditions that are similar to the ones that we used for congruency. Now, take a look as the ones that I've highlighted over here. These are the four conditions that you can use to prove that a triangle is similar with another. Now, it's really important that you understand that when we were using the SSS condition for congruency, we were proving that those sides were equal to each other because they had to be congruent, same size, same shape. When the triangle, or you're proving that two triangles or two shapes are similar, you're not proving that the sides are the same, but you're proving that each of the sides are proportional to the sides on other side. So you have to check if that condition works. If in order for you to go, oh, well, do they have the same scale factor? Each of the lines in accordance to the corresponding line on the other side, then you can use SSS. Same thing with SAS, but with SAS, there's an angle in between that's equal. Triple A means all three angles have to be the same. The good thing about triangles, though, is that if you can prove that two angles are equal to each other, then the third angle has to be due to the angle sum of the triangle. So angle sum of the triangle is consistently 180 degrees. If you prove two, then the third one will just be consistent and same as the other one as well. And finally, there's the final one, which is the right angle triangle that had to have the same hypotenuse, or the hypotenuses have to be proportional, and also with side. Okay, so let's see what this looks like when we start doing some examples. I'm gonna put, just like you should have, I'm gonna put all of the conditions on my right here. So if you have your booklet with you, this would be the perfect time to have that next to you as you're doing the work, but you will also be obviously copying this down as I'm doing the examples for you. Let's look at question A. Okay, straight away, once again, just like congruency, you should be spotting which one of these four are you going to prove by looking at what we're given. From here, you can see that we're given a side here, so I'm just going to highlight these. A side here, another side here, and an angle in between. So it looks like it's going to be an SAS proof. Okay, I'm going to write that down if you'd like, just so you remember that it's going to be an SAS proof. So here's how you prove that the sides are proportional. You can say that, let's say, uh, well, we could look at the corresponding sides. So let's do that. Let's look at this side. We can highlight this side 1.5 and this one 3. So we can say that, so we can look for the ratio here by first going, okay, so ED, which is the length ED here, by the way, if you don't know what that is, ED over BC, or should I say, yeah, BC, or BA, sorry, not BZ, BA, is equal to ED is 3, BA is 1.5, and so this is equal to 2. This doesn't prove anything yet, this just gives us a ratio, but I'm just going to write S here anyway, because that's a side. Now, as long as you ensure that the other side that we have also has this same ratio of 2, this is important, as long as we can prove that, then we've proven that these two sides are fulfilling those conditions of having the same proportion. So the other side that's been given to us is let's see here, it's FD over CA is equal to FD is 4, CA is 2, which is equal to 2. So as you can see, both of these sides are actually have the same ratio. So these are fulfilling those conditions. And finally, when I want to find to see if the angles are the same, remember to write the notation correctly. This is angle BAC is equal to angle EDF, and because they're given it to you, you should tell me what the angle actually is, and then you can write given as your reason because it's actually given on the diagram. And finally, you can have A at the side. So now you've proven, therefore, okay, triangle ABC is similar. Remember, this is the symbol as triangle DEF, and then you can highlight a bracket SAS completed. Okay. Now, feel free to pause the video to copy those examples down, but it's really important that if you're using these conditions, especially with sides, you're testing to see if the sides have the same ratio. Okay, if they don't, then they're not actually similar triangles. Now, let's take a look at B and see if we can do B. I'll have to move this away a little bit, see if I can do that. Question B. Okay, I'm looking at what they're giving me, and I see that we have an angle here and an angle here. So they're giving me actually two angles. Okay, no sides. I don't see any side information. So it's likely going to be the triple A situation. Okay, so let's try this. So we'll do the 40-degree first. So angle DEF is equal to angle, be careful you match up with the correct corresponding angle, ACB, which is equal to 40 degrees because it's given to us. Okay, it's given to us. Cool, so that's A. Should probably move this a little bit more. That's A. Okay, so wait, let's put that away. A. Okay, let's do the other angle. So the other angle is a angle ABC is equal to angle EDF. Okay, EDF, which is equal to 65 degrees, which is also given, which is also an angle. Now, you might think, yeah, well, we're done. Well, actually, we're not. We need to fill triple A, but then they haven't given us the third angle. But remember, angle sum of a triangle. So let's just write the third angle. Angle CAB, which is the angle we don't actually know yet, is equal to angle DFE. Okay, and we can actually just work out what this angle is, or we can just say angle sum, because we're implying that this angle has to be equal because the angle sum of a triangle is consistent. So angle sum, and then you can write A here, and now you fulfilled the condition, so you can write therefore triangle ABC is similar to triangle triangle, I have to write the triangle sign, DEF, because A. There you go. You're done with that question there. Okay, now finally, we can also use similarity to prove these, and then use similarity. Once we know it's similar, we can now prove or show or calculate specific length sizes. But we'll do this first. So we had to prove first. Okay, let's see what they've given us. Um, it looks like they've given us angles that we could possibly use. We don't have enough side information. I know it's tempting. We're looking at this right angled side here, and we're going, oh, that's tempting. Might be RHS, but they haven't given us the H. They haven't given us the H length, so we can't actually use RHS. But we can actually use, even though they haven't given us the angles, we could look at angles to do. So I'll give you I want you to think this through. Okay, we're definitely going to say this. Angle ABC is equal to angle ADE because both of these angles are 90 degrees. Okay, this is not given, but you can see that this is clearly vertical line going down and these are horizontal lines that's matched up with the circles in the cone. So it's 90 degrees. So this is actually both equal to each other. So we can say that this is A. Okay, that we can prove by looking at this diagram. Now, what we also know, what we can also find out or figure out is that angle BAC, which is this top angle over here. So I'll just highlight it so you can see this angle right here. Okay, ABC or BAC is also equal to angle DAE because it's actually shared. I don't know, actually, we don't know what this angle is, but these two are definitely equal to each other. And the reason is they're common, right? It's a common angle. They both share that same angle. So this is A. And once again, we've done this already before in the other question. We can say angle, whatever the third angle is, ACB is equal to angle AED because of angle sum, right? Once you've proven two angles are the same, the third angle has to be the same if it's a triangle, if you're comparing triangles. So we've actually got, therefore, triangle ADE is similar to triangle ABC. There, you've already proven it, okay? And now, because we know that they're similar triangles, they're telling us that AD, okay, so they're giving us new information. AD, right here, I should probably use a different color pen. AD right here is actually 1 centimeter. Okay, that actually gives us a lot of information for us to use because now we can use something like this. Remember, proportion has to be the same ratio, same scale factor, right? So we'll go AD, which is the line, the small triangle. Underneath is AB. The ratio AD to AB has to equal to the ratio of, let's find another side that gives us both sides. I can see that well, actually, this one already gives us both sides, but we're also looking for, let's say BC gives us a side, right? So BC is the bigger one, so that goes to the bottom, and D up here. Okay, we're looking for what? What are we looking for? We're looking for D. So we had to find D. So in one, we could swap this over. In fact, maybe I'll do that just to make it easier for us. So we'll do this and put the equal sign here. Whoops, put the equal sign here. Okay, now let's substitute what we know and leave what we don't know. I don't know what DE is yet, so DE stays the same, but I do know what BC is. BC is 2. Do I know what AD is? Yes, they gave it to us, so it's 1. And do I know what AB is? Yes, I do. It's 4. Okay, and then just a simple algebra times 2 here, times 2 here, which will cancel the 2's here. And finally, D is equal to 2 over 4, which is equal to 1 over 2 centimeters. Okay, that's all it is. That's all we have to do. Okay, once they give us enough values, we can then you can use, as long as these sides, the main thing you need to remember, these have to be the corresponding sides on the triangle. So you can see here that AD is the vertical line on the smaller triangle, and AB is the vertical line on the larger triangle. Okay, as long the corresponding sides, you can do this and then use algebra to figure out the missing value. Okay, give the questions a go. Hope it goes well.